All right, let's continue. So this problem says, in Rhombus math, the coordinates of the endpoints of the diagonal MT are 0, -1 and 4, 6, right? Okay, now it says, write an equation of the line that contains the diagonal AH. Okay, use of the set of axes below is optional. And when they say below, well, I didn't put it below, I put it next to it, it doesn't matter. So let's see what happens. Let's just graph this and let us explain what's going on. Let me make this smaller. Oh, okay, here we go. So what I did is I plotted the points 0, -1 and 4, 6. Okay, so these are my 2 points. There you go. Now, these are the endpoints of the diagonal of what? Of a rhombus. So what do I know about the rhombus? Well, all sides are congruent. Also, opposite sides are parallel, and diagonals bisect each other and are perpendicular. What does that mean? Well, when you say that they bisect each other, that means that they touch each other at the midpoint. And when we say that they're perpendicular, that means that they form 90-degree angles, right? Okay then. So let me actually do this algebraically because I'm having trouble visualizing the graphic. Okay, so what I did is, since I know that diagonals are, they bisect each other, then I found the midpoint between M and T, between these 2 points, okay? And I found out that the midpoint, okay, look at this is how I found the midpoint. You add the x's and divide by 2, you add the y's and divide by 2. So for example, it was 4 plus 0 divided by 2, and then it was 6 plus -1, okay? In other words, 6 minus 1 divided by 2. So my midpoint is 2, 5 over 2. In other words, 2, 2.5, right? Okay, so that takes care of the midpoint. That's the midpoint, 2, 2.5. In other words, it will be like this, 2, 1, 2.5 right here. That's the midpoint. See that? Nice, right? Cool. Now what else? Well, the question says the following. It says, write an equation of the line that contains diagonal AH. In other words, now I have to find or write an equation that contains this diagonal, the diagonal that is perpendicular and crosses at the midpoint. The other one, the other diagonal of the rhombus. All right, not a problem. So one thing that you also have to know is that this is one endpoint of the rhombus and this is another endpoint of the rhombus. So there you go from there. All right, so I found out what the slope was. I got the midpoint, I got the slope. The slope is 7/4. So remember, since the diagonals are perpendicular, that means that they touch at 90-degree angles. Therefore, I have to figure out what the perpendicular slope would be. And I did. The slope is 7/4. But then the slope perpendicular to it would be -4/7. So from the midpoint, okay, right here, I would just have to go 4 down and 7 to the right, or 4 up and 7 to the left. I really don't know how to do it, so that's why I have to write the equation. How do I write the equation? Well, I'm gonna have to write in pencil because I might make mistakes. So to write the equation of the line, I do this. Y equals mx plus b. Correct? Yes? Okay. Now, what is the point that I'm going to be using? I'm going to be using the midpoint right here, because that's what the other diagonal is going to go through, right? The diagonal is going to go through the midpoint right here. So that's exactly what I'm going to use. So y is 5/2. But in this case, let's just say 2.5, right? Then the slope is -4/7. That's the perpendicular slope. The x is 2 plus b. Okie dokie. So now, let us do the math. Okay, this is negative 8 over 7 plus b. Now I am going to add 8 over 7 to both sides. So let's see now. Now look at this. I tried 8 over 7 and it gave me an irrational number, so 1.4. So I'm not gonna do it like that. And now I'm gonna have to actually turn this back into a fraction if I want to do it like that, correct? So sorry. So 5 over 2, right? Oh no, I don't have to turn it back. I'm gonna do it on the next stage. Okay, so I have 5 over 2, which is 2.5, plus 8 over 7, right, equaling b. So now what is 5 over 2? Let me see, alpha y equals 5 over 2, okay, plus, and then that would be what? 8 over 7. Alpha y equals 8 over 7. That's basically when I say alpha y equals, I'm doing the fraction thingy. And it's 51 over 14. So b is 51 over 14. So now I'm ready to write the equation. Okay? The equation of my line, okay, it's going to be, the equation of my line is going to be y equals the perpendicular slope, which is negative 4 over 7, okay, you put the x right there, and then plus 51 over 14. Okay, and that's it. That's how you do it. Wow. Oh, okay, the next question. In the diagram below, the circle shown has radius 10, okay? Angle B intersects an arc with length of 2 pi. This is the arc length of 2 pi. What is the measure of angle B in radians? Please, very easy. They're talking about arc length. So there's a formula that reads like this. Arc length equals to the angle theta times the radius. That's all you need to know. That's how you find arc length. And from there, you replace the information. So the length of the arc, it says, is 2 pi. Okay, now guess what? It's already in radians. Okay, we're talking about, well, we don't know yet, but the length is 2 pi. So they already have pi, so I'm assuming that they're talking about radians. What else do I know? Do I know the angle? No, that's what they want. So let's call it theta, or theta in Spanish. And then the radius. A radius is 10. Right? That's it. All I did was replace information that was given to me into the formula. Remember something. This is an angle in radians. But if in another question they ask you, what is the arc length, and the angle is not in radians and it's in degrees, you have to switch it to radians. I'll show you how to switch to radians, okay? Anyways, so if I want to solve for theta, all I have to do is divide by 10, right? So 2 pi over 10 equals theta. You understand why I have to divide by 10? I have to get rid of it. So now when I simplify this, I get pi over 5, correct? So your answer is pi over 5. There you go. Gucci? Alright then. Let's move on to the next question. Holy shooting. Okay. So triangle FGH is inscribed, okay, in circle O. The length of the radius OH is 6 and FH is congruent to OG. Alright, so let's see now. FH is congruent to OG. Alright, what do they want? What is the area of the sector formed by angle FOH? What is the area of the sector formed by angle FOH? They want to know the area, the whole thing right here, of this sector formed by this angle? Well, first things first. This OG is a radius. OF is also a radius. OH is a radius. Wow. It's a radius. So this angle right here and this triangle right here, what can you say about this triangle? This triangle is an equilateral triangle because all sides are congruent. That means that if it's equilateral, then each of the angles here, it's 60 degrees. Because remember, angles opposite to congruent sides are congruent. So this angle and this angle is the same. This angle and this angle is the same because of these two sides. So the angle is 60 degrees. Okay. Now let's figure something out. They want to know the area of this sector. So that means that I have to use the formula. Area of the sector is equal to, and I don't remember, I think it's the angle theta in radians over 2 times r squared. Right? Now, the angle is not given to me. It's too early in the morning. Oh my God. The angle is not given to me. Well, I didn't find the angle in radians. I found the angle in degrees, which is 60. Well, not a problem. Somewhere in here, I'm going to use my knowledge to turn 60 degrees. Look, 60 degrees into radians. How do you turn 60 degrees into radians? Easy. Radians usually will have something pi. Not all the time, but most of the time. So to turn degrees into radians, I multiply by pi over 180. So this becomes 60 pi over 180. Now what is 60 and 180 that I simplify? How many times 6 goes into 18? 3, right? So in other words, this is 3 pi. No, sorry. This cancels out because 60 goes in here 3 times. So this is the same thing as pi over 3. Okay? So how do you turn degrees into radians? Multiply by pi over 180 and then simplify and leave your answer as pi over 3 something, pi over 3, right? Over something. So this is pi over 3. So now, my friends, I'm ready. So the area of the sector is the angle pi over 3, okay, divided by 2, okay, times the radius squared, which is 6 squared. The radius is 6. We know that. Look, the radius is 6. Okay. Now, how do I divide these two? Well, you could either put it on the calculator or realize something, but this is just a technique that I'm using. I'm going to show you the other technique, okay? When you divide a fraction by a number, make that number a fraction as well. And then multiply the extremes and then the mids. So basically, pi times 1 is pi. 3 times 2 is 6. That's it. And now I'm going to multiply by 36, which is basically 6 squared. Right? Okay then. Now when I multiply this, what do I get? I get 36 pi over 6. And when I simplify, 36 divided by 6 is 6. So this becomes 6 pi. Okay? So what is that you have to remember? The formula to find the area of a sector. Now, as I told you I was going to show you something else. So I'm going to do it right here. We had pi over 3. That's what we had first. And the formula says that I have to divide by 2. So instead of going like this, I'm just going to say pi over 3 divided by 2. Okay? Times the radius squared. And now to rewrite this, when you are going to divide by a number, they said switch the multiplication, the division sign to multiplication, and flip the fraction. Well, this is 2 over 1, so this will be 1 over 2. And what do you get? Pi over 6, you see? And then you multiply by the radius square, and that's basically right here. All right? So your answer is 6 pi. Oh, okay. I'm not start writing in different. Okay. All right. What the hell is this? In the diagram below of circle O, diameter AB and radii OC, okay, are drawn. The length of AB is 12 and the measure of angle COD is 20 degrees. Okay, so we got an angle, and okay, what do they want? If arc AB is congruent to arc BD, okay, arc AB, is congruent to arc BD. I'm not getting this. What did I do? If arc AB is congruent to arc BD, I think they made a mistake. I don't think it's that. I think they meant arc AC. But anyway, let's do this. Find the area of sector BOD in terms of pi. Find the area of sector BOD. 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 They want me to find this area right here. So let me utilize what I know. All right. So to find area of a sector. To find the area of a sector is the angle divided by 2 times r square. Okay? That's how I do it. And let me see now. If it was given to you in degrees, well, if it's given to me in degrees, I have to do, let me see if I remember. If the angle is given to you in degrees, I think you do 360 divided by, no, sorry. It will be your angle divided by 360 times pi r squared. Yeah, that's what it is when the angle is given to you in degrees. So whichever you want to do, it really doesn't matter to me. All right. I'm going to see if I can do it both ways. All right. So here the angle is 20 degrees. Right? Now, arc AB is congruent to arc, well, AB, duh. Now, these two arcs are congruent. How do I know that? Well, think about it. This is 180, right? So that means that this is also 180. Yes? Okay, now you already have, this is called a central angle. That's 20 degrees. So that means that you have 160 degrees running around. So then that means that this angle is 80 and that this angle is 80. Okay? Because the central angle, it has the same measure as the arc it cuts. So this is 80 degrees, 80 degrees. So now I have theta in degrees. Okay? And I can actually figure it out now. Wait, I need the radius. Whichever formula I use, I need the radius. Okay, fine. The radius is 6 because the whole diameter is 12 from what I'm seeing here. Okay, so let's set it up. I'm going to use the degree formula, okay? Area of the sector is equal to, well, the angle, which is 80 degrees over 360, right? In other words, any part of the circle is but a fraction of the whole 360 degrees. That's basically what this is. Okay, well, just like when you eat a pizza, slice of pizza, it's, you ate 2 slices, so you ate 2 out of 8, right? 2 out of the whole thing. All right, so 80 over 360 times pi, and then the radius square. All right, so let's figure what that is. see. Okay. Oh, and the answer I'm supposed to leave in terms of pi? Okay, cool then. That's not a problem. So let me see now. 80, okay, so what is 80 over 360? Not a problem. Let me see now. Fraction alpha y equals 80 over 360. Uh-oh. Oh, okay, 80 over 360. And that is 2 over 9, right? 2 over 9 times 6 is 8. Okay, so 80 over 360 is 2 over 9 and then times pi times 36, which is basically 6 squared. So when I do that, okay, 36 times 2 is 72, divided by 9 is 8. So this is equal to 8 and then pi. So the area of the sector BOD in terms of pi is 8 pi. If they said to the nearest tenth, then I would have to turn this pi into 3.14 and multiply, correct? Okay, just remember that. All right, let's move on. Okie dokie. So here, once again, and if you already know how to do this problem, then just do it. Don't wait for me. All right. They want the measure of angle N. They want the measure of angle N. They want this measure right here. Well, in order to do that, let's see what kind of information I have. The length of NL is 6. NL is 6. Okay, so this whole length is 6. So we already know what's going on. We know that the radius is 3. Aha. Now, they want to know the measure of angle N. This is an inscribed angle. But in order for me to do that, I will have to know what the measure of this central angle is. Well, we know that the radius is 3. So this radius is 3 and this radius is also 3. So that makes this an isosceles triangle. Okay. So the area of the shaded sector, oh, okay, now I didn't read this. The area of the shaded region is 2 pi. Right away we know what they're talking about, area. So let's bring out the formula for the area of a sector. So remember, the area of a sector, I'm gonna put it right here. Area of a sector. Area, if we're talking about radians, is pi divided by 2 times r squared. If we're talking about degrees, we know that is the angle over 360, right? Times pi, the formula for the area of a circle, times pi r squared. That's basically what it is, okay? So I'm gonna use this one, okay? Just because it says that the area of the shaded sector is 2 pi. So let's see. Area equals to theta over 2 times r squared. That's what I know. So area, 2 pi, is equal to the angle, which they're not giving me, divided by 2 times r squared. Yes? Okay then. So now, when I do all this, I get 2 pi is equal to 9 over 2, right? Yes? 3 squared is 9. Oh, times the angle, sorry. So 9 theta, okay? And now, all I'm gonna do is multiply by 2, okay, and divide by 9, basically. In other words, all you have to do to get rid of this fraction is multiply by the reciprocal. Okay? When I multiply by the reciprocal, these cancel out. 2 divided by 2 is 1. 9 divided by 9 is 1. So, and over here I gotta multiply. 2 times 2 pi is 4 pi over 9, right? And then that should equal the angle theta. Now, no funny thing. Let's see now. What am I not doing right? Oh no, it's fine. But now, this is the measure of this angle right here, guys. Okay? And remember, this angle right here is half of that. So what is half of this? 4 pi over 18, because half of this will increase the denominator. If you don't believe me, you could do it. Alright, but so what? That's not any of our choices. Oh, I know why. Remember, I used the formula that was given to me in radians. So what? Well, maybe if we turn this into degrees, because we have radians right now, because that's what we use. If we turn this into degrees, we'll figure out how many degrees. Okay, fine. And how do you turn that into degrees? Well, that's easy. Multiply. Okay, to turn degrees into radians, you multiply by pi over 180. To turn radians into degrees, you multiply by 180 over pi. See that? So this cancels out the pi. You see that? Alright, so now let's do the multiplication. Okay, so first of all, I want to know what is 180 divided by 18. That's 10. 180 divided by 18 is 10. So I have 4 times 10. Okay, which is equal to 40. Ah, you're nice. Now, I could have avoided this conversion if I had just followed the formula that is given to me for the angle in degrees. Alright? Alright, cool. So remember, the angle is 40. Now, if I had converted from these radians to degrees, I would have gotten an angle of 80. But the thing is that this is just the central angle right here. This will be 80. But I had to divide by 2 because an inscribed angle is always half of the arc or half of the central angle. Oh, baby, 40. Okay, let's move on. I have no idea what that says, and I'm tired already. It doesn't matter, Becca. It doesn't matter. Alright, so what am I supposed to do? It says a designer needs to create perfectly circular necklaces. The necklaces each need to have a radius of 10 centimeters. What is the largest number of necklaces that can be made from 1,000 centimeters of wire? Alright, here we go again. Look, do I have a compass over here? Do I have a compass over here? Can I have it now? I've been too boring. Oh, hey, seriously, where's my compass at? Yo, people thieves in this house. Oh, you know what? Screw it, I can do a perfect circle. Alright. Okay, so that's a necklace. Okay, perfect circle. You saw that, right? It's not like I need to draw. Oh, I found it. Well, too late. I already made my perfect circle. Alright, so it needs to create perfect necklaces. Each necklace has to have a radius of 10 centimeters. Okay, so the radius here is 10 centimeters. Okay, now, what is the largest number of necklaces that can be made from 1,000 centimeters of wire? So I have 1,000 centimeters of wire. So let me find out what is the circumference of circumference is the distance around the necklace, right? Let me find out the circumference. So what is the formula to find the circumference? Well, it's 2 pi r. Okay. And the radius is 10, so the circumference is 20 pi. Okay? Now, this is how much it's needed to create one necklace. Alright? So now let's figure out how many necklaces can I do with 1,000 centimeters of wire. So then what do I get? Okay, 1,000 divided by what? 2 pi. And I'm going to show you how to write it on the calculator because some of you are going to make a mistake. So it's 1,000, see that? Divided by, and I'm going to do the following. 2 pi, and close parentheses. That tells the calculator divide the whole thing by 2 pi. Okay? Now, I'm going to show you the difference between that and this. Divided by 2 pi. See? Two different numbers because the calculator thinks that it's going to divide by 2 and then it's going to multiply the whole thing by pi. So this is what you got, okay? And anyways, I think I made a mistake. I divided by 2 pi. I'm supposed to divide by 20 pi. So let me just go over here. I'm going to go here. You don't know how to do that, so that means that you have to redo it again. Okay, 1,000 divided by 20 pi. 20 pi is the length. So I got 15.9. So this is 15.9. So you guys don't think about the consequences of not thinking because you think not too hard. No, I'm just kidding. Look, you can create 15.9 necklaces. So in other words, how many necklaces are you going to give to the customer? 16? If you said 16, you're wrong. You don't have enough wire. So you can only make 15 the maximum. Because you're not going to give him 0.9 of a necklace, correct? Alright. Oh, nice. Oh, okay, here we go again. In the diagram below of circle O, the area of the... Okay, area, that's it. I know what formula I need to use. Either... Wait, no. Let me wait until I see which... how they give me the angle or whatever. So the area of the sector AOC, okay, is 12 pi inch. And the length of OA is 6 inches. Determine and state the measure of angle AOC. Okay. Funny thing is that I don't see the... Hello, how you doing? Good. You good? Okay. I don't see them telling me whether the angle should be in radians or in degrees. So, you know what? I'm gonna give it to them in both, just in case. Let's start, but I'm gonna start with the degree formula. So the area of a sector in degrees, right? The area of a sector in degrees is theta over 360 times pi r squared. Yes? Okay. So the area of the sector is 12 inches. That's what it says. So 12 pi, right? Equals the angle divided by 360 times pi times times the radius square. Yes? Okay. So now I am going to do the following. I am going to simplify this right here. So let's see, 6 squared is 36. 36 over 360. Okay? So you're going to have 12 pi equaling, okay? 36 over 360 is 1 over 10. 1 times theta, so this is 1 over 10. When you simplify this over this. Now I need to figure out the angle. Right? So the angle, I'm going to multiply by pi r squared. Wait, something is not right here. Oh, okay, sorry. This is 36 pi. I don't know why I got rid of the pi. So this is theta pi. Oh wow. Okay, so I am going to multiply by 10 to get rid of this 10. So I'm gonna have 120 equaling theta pi. I multiply by 10 to get rid of this. Now I have 120 divided by theta pi. And 120 what? Pi, sorry. When I multiply by 10, I get 120 pi. Now I'm going to divide by pi on both sides, and I'm going to get theta to be 120 degrees. Make sense? Yeah. And if you want to turn this in, 120 degrees. And if you want to turn this into radians, just in case they were to ask you for radians, how do you convert degrees to radians? You multiply by pi over 180. Okay? And then you simplify the fraction, and you're going to have something pi over something, and that's it. Okay? Oh my God. All right. I don't know. I need a break, so I am going to take a break.